So your exam will be partly in Canvas and partly written. The Canvas portion will be some of the simpler questions, and you will not be required to show work there. A lot of those are calculator type questions also, typically. And the written portion, you will take a picture of your work and upload it. And on the written questions, you do want to show all of your computations in order to get full credit. So let's take a look at this first problem here. We are checking some of the definitions, identifying different concepts here. So we're doing a quality control check on 250 units of plasma. So we are checking some plasma here. They are randomly chosen, that's a key word, from the manufacturing line at Adventis Bearing. And we are checking for contamination. The number of contaminated units is recorded, so that's important. In order to determine, so those two words are telling you using inferential statistics, so to determine if the manufacturing process at the company meets FDA standards. So find the population of interest, so that's the entire group that we're considering. So we've got these 250 units of plasma. That's not going to be the entire population. The entire population would be all plasma at the factory. So all plasma at Adventis Bearing. Your sample would be the 250 units of plasma. So it's not 250 units of M&Ms here. So you got to be specific and tell the specifics of the sample here. Variable of interest, your number of contaminated units is what's going to be recorded. So that's our variable. So number of contaminated units of plasma. Is the variable quantitative or qualitative? Well, it's a number here, so it's going to be quantitative. And then is it nominal, ordinal, discrete, continuous? Well, quantitative variables are either discrete or continuous. The nominal ordinal goes with qualitative. So, and then number of units would be counted. So this would be like 1, 2, 3, etc. So that's going to be discrete. So discrete is counted, continuous is everything in an interval. And continuous is usually measured, like time or weight. Does the study involve inferential or descriptive? We already said those keywords to determine are telling us this is inferential statistics. If inferential, what inference might be made? Well, if there's, for example, if there's low contamination in the sample, then that could imply that there is low contamination in the population. So in all plasma. At Adventis Bearing. If there was high contamination in the sample, then that could imply that there is high contamination in all plasma. And then that would mean something's possibly wrong with the manufacturing process and they need to find out what's going wrong and make some changes. So, and then of course, this process of whether or not low contamination in the sample does indeed mean low contamination in the population, we're going to figure out how to do that later. So these are just possible inferences. How likely is the sample to be representative? So representative means this sample has the same characteristics as the population. Well, these 250 units were randomly chosen. So usually randomness will give you a representative sample. So we would say that this is likely since selection was random. Now, if they didn't tell us it was random, it would be unclear. We couldn't tell how representative it was. So sometimes it's not clear. Sometimes it's clear that it's not representative. Say you were doing polling to, see who people are going to vote for in the next election. And if you did polling, say, just among Democrats or just among Republicans, took your sample of just Democrats or just Republicans, that's not going to be representative of everyone on the whole. Or if you took your sample, say you're trying to determine nationwide who people are going to vote for. If you took your sample just from Illinois, that would probably not be representative, because people in Illinois, on the whole, may have different political opinions or preferences than people in other states. There's conservative states and liberal states and everything in between. So you'll look at a similar example. 2 here, we're classifying some variables as, sorry about that, quantitative or qualitative first, and then nominal, ordinal, discrete, continuous. So remember, quantitative variables are numbers, and they can be discrete or continuous. Qualitative variables are categories, and they can be nominal, which is strict categories, or ordinal, ordered categories. So number of individuals served at a food pantry in a week. So the number, so that's definitely going to be quantitative. And then discrete is things that you can count. Continuous is things that you measure. So discrete here is counted. And continuous is measured. So number of individuals would be like 1, 2, 3, 4, etc. That's counted. So this is going to be discrete. It's not going to be measured like a liquid, between 2 and 3 gallons. The make of an automobile. So a make is a category. It's not a number. So that's going to be qualitative. And then nominal is just categories. Ordinal is ordered categories. So the make of an automobile, Ford, Toyota, Chevy, Acura, those are just categories. So that's going to be nominal. They're not ordered. The amount of coffee consumed by a person in 24 hours. So you would measure that in cups or ounces or liters, for example, and you can subdivide cups and ounces infinitely. So it takes on everything in a range. So amount of coffee is going to be quantitative. And then it's going to be continuous because it's measured. So, for example, 0 to 32 ounces, fluid ounces. So, or anything in between. Military rank of a member of the Army. So that's not a number. So you've got, private, sergeant, colonel, etc. So that is going to be qualitative. It's non-number data. And then we just have to decide nominal or ordinal. Well, they're categories, but they have an order, right? A sergeant is above a private. A lieutenant is above a sergeant, for example. So this is going to be ordinal. All right, next up here, we are making a stem and leaf plot of the data, and these are weights of premature infants. We're going to interpret our results. So to interpret the results, we're going to use that acronym SOSS, C-O-S-S, Center Outlier Symmetry Spread. So here's our weights here, and they are decimal data. So we are going to use the tenths place here is going to be our leaf, and then the ones digit is going to be our stem here. So we can either go from high to low or low to high, doesn't matter. Let's see, let's find our low here. So I see a 2.9. And then I don't see anything smaller than that. And then for the high, let's see, I see a 7.1. I don't think I see anything higher. So we've got from 2 to 7, and these are in pounds. Okay, so 2, 3, 4, 5, 6, and 7. There's our stems. So let's go through and get all the 2s first. So I've got a 2.9, and I don't see any other 2s. So we got 2.9. Now let's do our 3s. So we've got 3.5, a 3.8. So 3.5 and 8. So we want to put the 5 first, followed by the 8, because remember, we want to increase as you go from left to right. And then in the 4-pound range, we've got 4.2, 4.6. So 4.2 and 6. So 2 and then the 6. So that means 4.2, 4.6. The 5s, we've got 5.8, 5.1, 5.4, and 5.9. So we had 1, 4, 8, 9. So 1, 4, 8, and 9. In the 6-pound range, we've got a 6.4, 6.6, 6.4. So 4, 4, 6, 2 6.4s and a 6.6. And then the 7, we just have the 7.1. So there's our stem and leaf plot. And then the center. So we're just estimating here. So center, it looks like our center would be somewhere in this row. We'd have 1, 2, 3, 4, 5 above that row, 1, 2, 3, 4 below. So let's see, probably in the middle of this row, so maybe about 5.5. So 5.5 would be in here. We would have 1, 2, 3, 4, 5, 6, 7 below, 1, 2, 3, 4, 5, 6 above. So 5.4, 5.5 approximately. Outliers. So remember, outliers are away from the data, away from the rest of the data. So as I look at this data, I don't see any gaps in the data. So I would say none, no outliers here. There's nothing that looks like it's really far away from the rest of the data. And let's see, symmetry. So if we put that curve across the top of the data here, it looks like it'd have a longer tail going towards the lower values than the higher values. So this looks like it's kind of skewed or pulled off to one side. It's not symmetric. It's not too far off of symmetric, but slightly skewed. And then spread of the data. So we can tell low 2.9 to 7.1. That's actually the range of the data. So we can tell the low and high roll off real quickly. And then we can see that most of the data here is concentrated in like the 5 to 6 pound range. So that's our assessment of the data. And then next up here, we are doing a grouped frequency histogram for the following data. And we're using equal class sizes that start with 50 to 99, 100 to 149, etc. So let's see here. So let me give myself a little bit more room. There we go. So let's put our table over here. So we're going to do our class and then our frequency. So we're starting with 50 to 99, which is a class width of 50, and then 100 to 149. And then let's see, what's our high here? So 189, 212, 245, 289 looks like our high. So we have to include a 289. So 150 to 199, 200 to 249, and then 250 to 299. So let's count how many we've got in that 50 to 99 range. So let's see. So there's 1, 2, 2. So a frequency of 2. So when you study using tick marks, I just counted them off. In the 100 to 149 range, we've got 1, 2, 3, 4. So a frequency of 4. 150 to 199, 1. Oh, wait. 100 to 149. Looks like I missed the 102. Let's back up here just a second. So we had 1, 2, 3, 4, 5. So frequency 5. 150 to 199, 1, 2, 3, 4. So 4 there. 200 to 249. Oh, 5, right? Got another one that I missed. 189. And then 200 to 249. 1, 2, 3, 3. And then 250 to 299 is that last one, 289. So there's our frequencies. And let's see here. Let's just add these frequencies up. So 2 and 5 is 7, 5, 12, and 3 is 15, and 1 is 16. And we've got 4 columns of 4, 16. So we got everything in there. And we're doing the frequency distribution. That's this part. And then we're doing the histogram. So the histogram is the graph. So we want to do on our vertical frequency. And on our horizontal here is going to be our class. These are triglyceride levels. So this is going to be, sometimes they just call those triglyceride TG. Okay. So we are going to start here at 50. And then 50 to 99, the 100 is the dividing point. So we'll do 100. 150, 200, 250, and 300. And then our frequencies go from 1 up to 5. So 1, 2, 3, 4, and 5. So that first frequency is 2. So we'll have a bar of height 2 from 50 to 100, like that. Then I'll have a bar of height 5 for 100 to 150. So like so. Another bar of height 5 for 150 to 200. Like so. 200 to 250, a bar of height 3. So like that. And then a bar of height 1, 250 to 300. Like that. So there's our histogram. And then we could tell some things about the histogram here too. I didn't ask you for that. If I did ask you for it, you can see that this histogram, remember with the histogram, you try and hit the middle of the bars here. So that histogram is slightly skewed to the right because the tail goes off to the right. It looks like the middle here is between 150 and 200. These values are fairly spread out. We're not seeing any consistent outliers because it's group data. So you've got to do both the chart, which is the frequency distribution, and the histogram. which is the graph. Now, if instead of frequency, if I said relative frequency, then remember for that one, that's telling you to do percents. So you'd have one more column in your table, which would be, in this case, we got 16. So it'd be 2 divided by 16, 5 divided by 16, 5 divided by 16, 3 divided by 16, 1 divided by 16, and you'd have those decimals. So that would be relative frequency. Didn't ask for that here, but wanted to remind you how to do that. All right, number 5. We've got some data here, 30, 40, 75, 65, 135, 100, 2000. We're finding mean, median, and mode of the data. So your mean, X bar, we'll assume this is sample data. You're just going to add things up here. So 30 plus 40 plus 75 plus 65 plus your 135, 100, and 2000. And we are going to divide by 2, 4, 6, 7. Let's do that on the calculator real quick. So we've got 30 plus 40 plus 75, 65, 135. And then 100 and 2000. Which gives 2445. We divide that by 7. 349.3. And then our median here. So for the median, remember we have to order the data, smallest to largest. So 30, 40, 65 would be next. Then 75, then 100, then 135, and then the 2000. And the median is the middle value. So we've got 1, 2, 3, 4, 5, 6, 7 values. So that's an odd number. So we've got 7 values. Take out the one middle value is 6 values left. Half of 6 is 3. So we got 3 below the median and 3 above the median. The median is going to be the fourth value. 1, 2, 3, 4. So there's our median. And we've got 3 below and then 1, 2, 3 numbers above. So median is 75. So median equals 75. And then the mode of the data, there's no repeated numbers, so no mode. Which seem to measure the middle well and why. We'll notice that the mean, 349, is really far from the median, 75. And the reason there's such a big difference is because we've got this outlier, 2000. All of these other values are less than 135. And then you got this one big value, 2000. So the outlier is pulling the average up. But remember, the median is not affected by outliers. So I would say the median here, because 2000, that particular value is an outlier. And mean's affected by outliers. So that pulls the mean up. It's not representative. Now, if the mean and median were pretty close, then we could use either one. That'd be symmetric data. But this is going to be skewed data because of that outlier. And then if it was categorical data, then mode could end up being the one that makes sense because you can use that one in categorical data. All right, now we're looking at spread here, range and standard deviation. So we want to find range and standard deviation for these 5 values. So let's see here. Range is high minus low. So your range is just going to be 9 minus 2. 7. And then for your standard deviation, remember what we have to do there is we have to find our x bar, our mean here, which is going to be 2 plus 3 plus 5 plus 6 plus 9, and divide by 5. So let's see, what is that? 15, 20, 25 divided by 5, 5. And then we want to do this table where we list the x value, x bar, x minus x bar, and then x minus x bar quantity squared. So our values 2, 3, 5, 6, and 9. And then x bar 5. And then we subtract our column. So 2 minus 5, negative 3. 3 minus 5, negative 2. 5 minus 5, 0. 6 minus 5, 1. 9 minus 5, 4. And then we square this column. So negative 3 squared is 9. Negative 3 times negative 3. Negative 2 squared is 4. 0 squared is 0. 1 squared is 1. And 4 squared is 16. And then remember what you do is you sum up that last column. So let's see, we've got 16 here, and that 4 would make 20, 30. So then our variance, s squared, is the sum of the x minus x bar squared divided by n minus 1. So the sum of the squared deviations, that's the 30. And then n, we've got 1, 2, 3, 4, 5 numbers. So that'll be 5 minus 1. So 30 divided by 4. 7.5. That's your variance, and then your standard deviation s is going to be the square root of the 7.5. So let's go ahead and do a caret 0.5 power. So about 2.74. Because square root's the same as 1/2 power. So there's our standard deviation. And we can also do these. Let's see here. Find range and standard deviation. Okay, so we can also do these in the calculator. So if we go to, let me clear this out. If we go to stat and edit, we can edit our numbers in a list here. So we had 2, 3, 5, 6, 9, and I want to delete that guy. Okay, whoops. And then we want to go to stat and calc and one variable stat. So we press enter. Our list is in list 1. We'll come down here and calculate. And so there's our x bar of 5. That is the same thing that we got here. Our standard deviation, 2.74. And that's what we got right there. So that double checks us. Remember the sigma x, that's the population standard deviation. We don't use that because we're not dealing with population. Oh, and on the previous question, mean, median, mode, we could enter that data in the list and it'll give you median here. And then, of course, your mean is your x bar up top. So we could have done that with these numbers here. In fact, let's do that real quick just to double check our work. So let's go to stat, edit, and we had 30, 40, 75. And then 65, 135, 100. And then the 2000. So there's our data. I'm going to go to Stat, Calc, and one variable stats. Come down to Calculate. So X bar 349.28. That's what we got here, 349.3. We scroll down here. Our median, 75. That's right there, 75. And that double checks our work there. So remember, you can use the stat features to double check. Of course, if I have you do it on the written portion, you're going to have to, write out the details. Number 7, we are doing a box and whisker plot for this data here. Label what each number represents on the plot. What's the significance of the box and the diagram? Oh, you know what? I forgot part B here. Sorry, back up the bus. Describe what standard deviation means in words. What does it mean if data set A has a higher standard deviation than data set B? Okay, so standard deviation measures the spread or the variation in the data. So B, so S measures the variation / spread in the data. And then if data set A has a higher standard deviation than data set B, that means more spread. So higher S means more spread or more variation. Now that one's set. Now we're ready for our box and whisker plot. So remember, with the box and whisker plot, we have to figure the quartiles and the median and then get that IQR, that interquartile range. So we first have to take this data and order it from smallest to largest. So let's see, I see a 32 here and then a 35. Oh. And then let's see, in the 40s, oh wait, we got a 38. And then in the 40s, we've got a 41 and a 46. And then we've got 52, 54, and then 68. Okay, so we've got 2, 4, 6, 8 values. So n equals 8. That's even. That means there's 2 middle values. So you take 8, divide by 2 is 4. So half the value is below the median, half above. So 1, 2, 3, 4. So our dividing line is there. Down from the top, 1, 2, 3, 4. So we've got 2 middle values, 41 and 46, and the median, we're going to average those. So our median is going to equal 41 plus 46, divide by 2. So let's compute that real quick. So 41 plus 46 is 87, divide by 2, 43.5. And then we need the quartiles. So Q1 is the median of the lower half. Well, the lower half has 4 values. That means that 35 and 38, 2 middles. So we're going to average those. So 35 plus 38, divide by 2. $36.5. And then Q3, the third quartile, that's the median of the upper half. So here's our upper half. It's got two middles, 52 and 54. So halfway between 52 and 54 is going to be 53. And now we can figure that IQR interquartile range. So you subtract the two quartiles. So 53 minus the 36.5. So 16.5. Now we want to figure the lower fences and the lower fence and the upper fence. So the lower cutoff and the upper cutoff for outliers. So the lower cutoff, you want to do Q1, the first quartile, and subtract 1.5 times that IQR. So for us, our Q1 is 36.5. We're going to subtract 1.5 times the 16.5. Let's compute that. So 36.5 minus 1.5 times 16.5, 11.75. And then we take Q3 and we add 1.5 times that IQR. So that upper quartile is the 53, and we're going to add 1.5 times the 16.5. So 53 plus 1.5 times 16.5. 77.75. So now we can, got all the pieces, we can draw our box and whisker plot. So draw out our number line here. And our low is the 32, the high is the 68, and this goes from 11 to 77. So we probably want to go from like 10 to 80 in our scale here. So let's do 10, 20, 30, 40, 50, 60, 70, 80. And let's go ahead and put the box above the number line. So remember the box goes from Q1 up to Q3. So 36.5 to 53.5. So 36.5 would be about right here. And then the 53 would be about right here. So this is Q1, this is Q3, and then we want to mark off that median 43.5 right here. So that's our median. We'll use a cap M. And then the whisker goes, the upper whisker goes up to the highest value that's not an outlier. Well, our outliers are anything past 11.75 and 77.75. So 11.75 would be about right here. And then 77.75 would be about right here. Well, the lowest value is 32, which would be about right there. And then the highest value is 68, which would be about right there. So our whisker is going to go from that Q3 out to the high value here. And then on the left side from Q1 out to that low value. So your 5-number summary is low, first quartile, median, third quartile, high. And those numbers are the 32, the 36.5, the 43.5, and let's see, 53 is Q3, and then our high is 68. So, and there's our box and whisker. No outliers here because we didn't have any values that were beyond the dashed lines, which were the lower and upper boundaries for our outliers, the fences, so we called them. What's the significance of the box in the diagram? So that box is the middle 50%. So this is part A, and then part B. Your box equals the middle 50% of the data, because it goes from the 25th percentile Q1 up to the 75th percentile Q3. And then our last question is computing percentiles here. So using the data from the previous problem, what is the percentile value of 41? And what is the 70th percentile of the data? So let me go grab that data. So right here, we'll bring that down. So remember, for percentiles, we use this equation here. I is the index or the place of the data value, K is the percentile, and N is the total number of data values here. So using the data from the previous problem, we want the percentile of the value 41. So 41 is right here. It is in the 1, 2, 3, 4th place. So A here. So I is equal to 4. N, the total number of data values here in the list, is 8. And then we can solve and find the K here. So if I is 4, we'll plug that in there. So 4 equals K over 100 times N plus 1. And N is 8. So this will be times 9. And then we want to solve for K. So let's multiply both sides by 100 over 9. And then the 100s and the 9s will cancel on the right. All that's left is K. On the left-hand side, we've got 400 divided by 9. And let's compute that real quick. So 400 divided by 9, 44.4. So our K is equal to 44.4. So it's approximately the 44th percentile, between the 44th and the 45th, but closer to the 44th. And then part B, what is the 70th percentile? So in part B, we are given N equals 8. And then the 70th percentile, so K equals 70. And we want I. So again, we're going to plug into this formula. So let me bring that down. So K there is 70 over 100. And then this will be times N plus 1. 8 plus 1, 9. So let's see, 70 times 9, 630 divided by 100. 6.3, I believe. Yeah, 70 times 9, 630 divided by 100. Yep, 6.3. So that's the index, or the number in the list for the 70th percentile. Now remember, if you get a decimal here, you average the numbers below and above that. So in the list here, we have this is 1, 2, 3, 4, 5, 6. We have a sixth value and a seventh value. 6.3 would fall in between those. So our percentile here, then our 70th percentile is going to equal the average of the 6th and 7th value. So we're going to take the 52 plus the 54 and, whoops, I wrote 52 again, 54, and we're going to divide them by 2. And that'll give us 53. So our 70th percentile is 53.